Good morning, everyone. I'm Robert Grover,
I'm Keisha Free. Baby Williamson.
I'm Patrick Valentine.
and we are Rapid Engineering. The mentoring firm is AES Consulting. Our site is 15 acres. It is located in Williamsburg, Virginia, just a minute or two off of Route 36, mile marker 64, mile marker 231. The client's needs for this project is to maximize the number of single-family residential lots. With that being said, the zoning for our site is R1, or limited residential. Two requirements for each lot is that it must be a minimum of 15,000 square feet, and at the front setback of 35 feet, it must have a minimum width of road frontage of 100 feet.
Okay, so since our property was originally woodland, there was no existing utilities directly on the site. But because all around it was developed area, there are several connections that we could have connected to. All access points are underground around the perimeter of the site. There are 2 waterway access points and a couple sewer points that we could have used. However, because of the topography of our site, this one right here ended up being our main access point since everything slopes downwards towards that direction. The main objective, as Rob said earlier, was to get the wooded area into a residential area, an R1 area. So each subdivision is a single-family dwelling unit, and the client's needs were to just maximize the number of lots and make it aesthetically pleasing. So in our first draft layout, we ended up making 27 lots. However, we also added a green space, but the green space is located up in lot 5, where only 4 residential lots could be accessed to that green space. We also had an on-site BNP. After revising that, we ended up making this layout, which has a maximum number of 29 lots, so we exceeded the last one. And also, we have a community green space, which every resident can have access to. It also helps with easements, so we could have, so we can run our water pipes and sewer pipes through it.
We have 2 roads on the site. Both of them are within a 50-foot right-of-way. And then VDOT standard 12-foot lanes and 5-foot grass shoulders, which also have 2% side slope. And they have stormwater drainage ditches on both sides. You see Hoagie Road is the main access road, and then Valentine Street is one cul-de-sac. This is the profile for Hoagie Road. We only have static vertical curves on our site, and the minimum for 25 miles an hour is 22. So the minimum for us is 32, so we met that. And then the low point is the intersection with Valentine Street for drainage purposes. And this is Valentine Street. This is where the intersection with Hoagie Road, and it drains downhill towards the cul-de-sac, which is right next to the BMP. This is our final grading. You can see one more time that all the streets drain towards the cul-de-sac and the BMP. The way we bulk graded this, on Hoagie Road, we did a 2% slope back from the road for 100 feet, and then tied into the existing terrain at 3-to-1 slope. We did the same thing on this side of Valentine Street, except we only had room for 70 feet to do that. The rest of the lots were graded with 70 by 70 foot building pads, which were then tied into the existing terrain as seen between 3-to-1 and 4-to-1 side slopes. We do have 2 detailed lots on the northern side of our plot, and those have 50 by 50 foot building pads with 10-foot stepped offset of a 10-to-1 slope to promote drainage away from the house. They also have a graded driveway and graded ditches. We do have ditches between all the other lots as well to limit lot-to-lot drainage. And we have the BMP, which is graded at the top of the screen, you can see, with a 3-to-1 side slope. And most of the site drains to the BNP, except for these 4 lots drain off the site. And the offsite facilities are capable of handling that extra runoff. We did have some trouble down here. This part of the site is only 50 feet wide, so we had to grade off the site. And we assume that the landowners will allow us to create a grading easement, otherwise we'll have to use a retaining wall. They do not allow us to do that.
All right, so pre-development drainage, there are 3 watersheds that are on the site. One drains off-site to existing properties, like Pat said, and then one drains towards the proposed Hokey Road, and one drains towards the proposed Valentine Street. And as you can see, the total time of concentration was 9.74 minutes, and that was taken from the most remote area of the site where drainage would stay on site. And the total volume and flow were calculated using the 10-year storm for a 24-hour event in James City County. And this table shows the aspects used to calculate time of concentration. And for post-development, the soil on the site is HSGB, which has low runoff potential and is mostly sandy with some clay. And the time of concentration has decreased 4.67 minutes to a little over 5 minutes. And the total runoff volume increased due to the imperviousness of the roads.
Okay, as I mentioned before, our BNP is a dry retention basin, which is designed for a 10-year storm and has a storage volume of 0.7 acre-feet. It's fed primarily with a 24-inch concrete culvert that runs underneath Valentine Street cul-de-sac and feeds the bottom of the BNP. There's an emergency spillway that spills towards the off-site stormwater drainage facilities. And the ditches on the sides of the roads are also designed for the 10-year peak flow. The Hokey Road has a grass swale with a 3-to-1 side slope and a 2-foot bottom width and 1 foot in depth. There's an 18-inch culvert that takes water from the far side of Hokey Road underneath the intersection with Valentine Street, so the water can reach the swales on Valentine Street. Once the flows reach Valentine Street, they're too high for grass slopes, so to lower the mains end value, we have to use concrete swales, and those are still at the 3-to-1 side slope, but the bottom width was decreased to half a foot.
Okay, here's our water piping system, and the line work is blue, see right here. We connected to the 2 existing conditions, 2 existing mains right here, and right here on Hokey Road. The mains run through the middle of the road, see right here. We decided to loop the main at Valentine Street back to Hokey Road because we didn't want to have a dead end to accumulate stagnant water and stuff like that. All pipes are 8-inch reinforced concrete, and we have laterals running from each to each lot, or at meeting water meters at the edge of the right of way. For these 6 lots up here, there was existing water main right through here, so we just connected them to there. Okay, here are the water line profiles for under each road. You can see Valentine on the left, Hokey on the right. There are 2 air release for the high points and they're both on Hokey Road, right here, right there, right there. And there's 1 blow-off valve for the low points, one on each road. Okay. Here's our sewer system, sanitary sewer system. It can be seen in the green lines, right about here. For our calculations, we use 310 gallons per house as divided by gram in the AES team. Also with a peak factor of 4. This was gravity driven, so on the northern part of Hokey Road, it runs south. And for the south of Hokey Road, it runs north and meets at this intersection of Hokey Road and Valentine Street. From there, it runs down Valentine Street to this cul-de-sac, and then goes left to the existing sewer main. All inches are 8-inch PVC, except for the lines south of the intersection, because it only needed to feed these 3 lots. So these are 6-inch PVC, while all the rest are 8-inch. And like the water, we, for these lots on the north, we just connected to the existing sewer.
All right, so our erosion plans, phase one was mostly initial grading and was used to protect exposed soil, and we used 2 construction entrances on Hokie Road. The sediment basin starts with this phase one and continues to be in the permanent structure on the site. Phase two is more construction oriented. The erosion dikes were to protect the perimeters of the site. Check dams were used in the grass swales and inlet and outlet protections at the culverts. And this is our final site layout. The cost estimate came to around $1,153,000, and we have 26 lots with a 35,000-foot green space for the community.
And one more thing, I know my teammate mentioned by accident that we have reinforced concrete water pipes. We don't, we have ductile iron.
And we'd like to thank AES for working with us and being so helpful. And do you guys have any questions?
Questions for the AES team? Graham, anything for these guys? Anyone else? Okay, nice job.